Coffee. I don't have a coffee command, do I? No. I can make a coffee command. I could do that. Let's make a coffee command right quick. Where's the display? Here it is. Alright, I'm not showing anything. Let's make a coffee command right quick. Let's do that. I'll put it down here. I code JavaScript like C because I'm a bad person, so, you know, there's probably better ways to do things than a plain switch statement, but it looks really simple, so that's what I use. Let's add a coffee command. Let's do that. And I don't know what kind of indentation we're doing, but whatever. Always. Now let's do this. Time to get another cup. We'll do that. That's fine. That's fine. And then I had turkey, so that's why I got the coffee to begin with. So we'll add a turkey. Let's add a turkey command. Obviously I didn't program enough at my job today, so taking it out now. We'll do, it's probably backslash, right? Yeah. It's tryptophantastic. We'll do that. That's not funny, but you know, that's what it's gonna be. So we'll save that. Let me reload. Obato. Okay, so now if I put in coffee, there we go. I should get the Unicode thing for coffee and put that in there. I'll do that later though, if I remember. I'm not gonna remember. There we go. There we go. Okay, let's actually start the game, right? That would be good. Let's start the game. Do play. Put on the game webcam. I know it disappeared. There we go. Let me turn off the other music. Alright. And the thrilling sequel. Is that a little bit loud? I can lower that. It might have been loud. It might not have been loud for you, but it was loud for me. Uno momento. Uno secundo. There's a game over here. Well, it's already at 14. I already lowered it. It's lowered on my desktop, maybe. The main menu is probably just loud, but I'll do that slightly. Okay. So the sequel is 7 Billion Humans. Go away forever. Eventually I'll buy it. Oh, 27 years. Look, I have gray hair now. It's destroying our soul, man. I'm a soul man. Okay, I don't want to start with a stupid hard one tonight immediately out the gate. Everything look good? Bitrate good? Everything's good. This is not a bald spot, by the way. Right? Over here. Where my hair parts. I got worried about it, so I looked in the mirror and stuff. My hair is very... The back where you get the swirly whirly thing, it does whatever it likes. My hair does whatever it likes back there. I don't look at it, I don't worry about it. But I got massive cowlicks all the time. Anyway, let's go to storage floor. So I did not do this. I think I read this last time. Oh yeah, indirect addressing. If you can hear my slurp and it's annoying, tell me and I'll I'll make sure you can't hear it next time. It's going to change everything. Imagine each thing is an address. And each address or address refers to a tile 0 to 9 on the floor. Okay, yeah, that's good. Pick up the letter at that address and outbox it. Okay, pick for each address in the inbox. Each address, okay, so each box refers to an address. This is 8, I guess that refers to box 8, which has the Y. For each address in the inbox. Well, why do we have an 8 then? Do we have to do the 8? Or is it just there for explanation purposes? I don't know. Pick up the letter at the address and outbox it. You can now access tiles on the floor indirectly. Observe this example to see how it works compared to what you've been doing so far. Oh, we got a little toggle switch. Cool. Okay. Toggles from there. But we don't have the number. If we pick up a number, we don't have the number available in here. Like if I pick up the 1, I can't just do like 1. You know, it's not like in a variable space we can pick up. I'm not sure how that's gonna work, if at all. I don't know, I guess we'll have to find out. Let's see what the example does. We'll just do that. Copies from 12, and then copy from box 12. Okay. We have to put it on the ground first. Okay. I gotcha. And I can copy 2 addresses as well. Interesting. What does that look like? Copy to the address at 0? You can't indirect to a tile with a letter, only numbers are allowed. It counts as that 0. Not sure I quite understand, but okay. I am pretty stupid though. Not sure I quite understand, but I'm gonna try and copy what we pick up to 10. Okay. And then copy from the address there, which I think is what they want, and then put that in the outbox. I think that's what they're talking about. So if we get a 5, I'm gonna copy from the tile whose number is on the thing inside of the 10. So it should take up the letter at 5. And then put that in the outbox. Okay, that is what they want. I saw an arrow there for a second. I saw the code doing its work. Oh, first try. Easy. I'm gonna eat that word in a second. It's not gonna be easy. I'll do one more and then we'll go for a hard one possibly. Maybe every 3. Drink storage floor, you're 30. Been working for 30 years. Special covert assignment. Management is requesting strings from the floor. Let's just process the strings and not read or discuss what they say. I'm glad SpongeBob didn't pick the secret string inside of my secret box. He would have seen this secret picture of the Christmas party. You don't want that? It would be impolite to read messages intended for someone else. Yeah, and forbidden. Yeah, I've run into that at work before. I have access to files I should not have access to, but you know, sometimes you need it for development requests. It's the honor system. Don't read what's in there. Each thing is an address of a tile on the floor. For each address in the inbox, outbox the item from the floor and all following items on the floor until you reach a 0. They give an empty space, so I'm assuming I have to put it like what I was doing. Like I have to put 1 there at least. And copy whatever data is from there. We need to do that first off, but then we need to... Okay. All following items on the floor. That means the thing that it addresses, if this was a 4, we would get 4, and then the address of 3, and then 2, and then 1. Until you reach a 0. Oh, because they put the zeros there. Okay, yeah, I think that's right. I think that's right. So then we have to bump the thing we got, and then do this again. All right. As long as it's not 0. Until you reach a 0. I don't think I include the 0, but I'm not sure. I don't know if 0 is inclusive for this or not. We'll find out. So we get the number from the address. If it is a 0, I think we're done. So we get the next item. If it's not a 0, when we put the item out, we bump it, we get the next one, and then we'll go back. Okay, so I think like that. So we get the 4. Get the data from the address 4, which is a T. We put that over. It's not 0, so we put it in the outbox. We lower the 4 to 3. We get the item at address 3, which is a 0. But this time I'm not sure if I put it on the outbox or not. So I guess we'll find out if this is an error. They wanted a 5. Why would they want a 5? All following. Okay, so I was doing all previous. All following would mean incrementing each time. Okay. We'll just change the bump minus to a bump plus. Easy enough. Easy peasy. So then they want the H. Okay, then we got a 0. But I'm assuming we don't use the 0. Yeah, we don't. Okay. So we should be good. It'll keep incrementing. It shows the arrows. That's cute. Sound's not too bad. That sounds still pretty short. Yeah, it looks like the audio's alright now. My face isn't covering anything like last time. We got it. Oh, that's my cursors. In a stream preview, I thought I had like a speck or something on the screen. It's my cursor because that's one of those days. Okay. We can use one less command, but the speed challenge is good. So how can we do this with one less command? We need to put something to 24. Copy from. I mean, we can copy to an address, but I don't think I should do that. I can't copy from an address in my hand either, so I think I do have to place it on the floor and then get it from there. If it's 0, I do want to get the next item. If it's not 0, I do want to outbox, get it, and get the next. But I might be able to do this with different, like, jumps. Maybe, but do I want to? I might move on. I might not expend too much brain power on these, trying to optimize them by staring at them intensely for an hour, because that's not guaranteed to work. That's just how I tend to solve problems. Can we do this with one? What would the one less instruction be? We at least need these two. Otherwise we can't get an item and put it out. And we do need probably a copy from. That's at minimum we do need 3. And we do need the increment, so minimum instruction count we need is 4. And we need a loop. But beyond that... Oh, I could bump? Okay, bear with me. I get rid of that. And I put this here. So I put it on the floor, I get the item where that's pointing to, because this is a pointer. Get that address. The item at that address, dereferencing that pointer. Then if it's 0, we get the next item. Okay. But if it's not 0, we put it out and then we bump it up. Ah, see, there we go. So that should be 7. Okay, that should be what they want. That's equivalent, but one less thing. That's not bad. That optimization's pretty easy. My phone over there. It is a lot of running around though. My guy's an old man. I guess he's got his stamina though. Great stamina. Worked on the floor for 30 years. He still seems happy too. I'm assuming he's not brainwashed. 7 commands or fewer. I want to see if somebody finagled that into using like 6. I don't think speedrun's the right word, but I'm sure people have videos of like making these in 5 instructions or some stupid crap. But those sound very interesting. I'll look up videos like that later, or maybe before I go to sleep. That sounds really interesting. Okay, small device. I like an easium though. I like easy ones. I'll try this. This is not gonna go well. Okay. Remember last time when I told you you didn't need to divide? Well, now you get to. Oh, I don't have division though. For each two things. Oh, I don't get addressing either. Not in this one. Yeah, we'll copy to 0. Okay, for each two things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers. Don't worry about divide by 0. Do not worry about remainders. Okay, we're getting the quotient. So last time I did this it was getting the remainder. This one's getting the quotient, so the opposite. Practice copying and pasting from a previous assignment. How do I do that? Oh. Well, I have to leave to do that. That's lame. That's okay. Module. Gotcha. So let's paste it into other rooms or emails, notepad, or anywhere emails. Hold on. That's good. It pastes its own. Oh, that's really cute. It pastes its own assembly. That's cute. And then it defines labels as just, you know, hash strings. That's all right. I like that. It makes it easy to share too. I don't mean cute in like a weird or bad way. It's just, you know, that's cute. That's cool. I like that. Okay. Let's go to the another small divide. Not a large divide, but a small one. Are you sure? I do. So this gets the remainder. So maybe ideally I can change this convoluted spaghetti to get a quotient instead. Copy to second. And then get the first one. Subtract the second from the first. Okay. How many times does it fit? So subtract the second number we got from the first number we got. If it's negative, the second number is larger. So ideally we will have had our result. So we copy from result, put it in the outbox. Yeah, because it doesn't fit into it anymore. That sounds right. That sounds right. If it's 0, maybe if it's 0, I probably want to copy from result as well. I don't know. Negative or 0. Negative it goes. Yeah, or 0. Otherwise, we copy from result. Okay, and subtract the second again. No. Not for this one, at least. So subtract the second number from the first number. If it's positive, we still have somewhere to go. So it's not going to be negative. So it's going to go here. Copy to result. That's fine. It's not going to be 0. Actually, I'm going to do this. We'll copy the result first. It's not going to be negative. It's not going to be 0. If it's positive, I want to keep subtracting. So subtract second from result. Yeah, that should be okay. But this is not, no, actually, it won't be okay, but I forget how this works in the game. It works differently from my mind. So I subtract the second from the first, which is a 6. I subtract the 2 from there. If I had 8 and a 2, I do want the 4. But I'm not. I'm going to keep subtracting until I get 0. Then I'm going to put over 0. So yeah, this gets the remainder. This is going to go the remainder. He doesn't want that. Okay. Okay. How do you get a quotient with only addition and subtraction? Information should be, yeah, that's updated. Okay. We subtract it twice, we get a 4. Do I need to keep another thing? No. Adding it won't work. I'd have to see if it's like a multiple. Or a factor. Ideally, it would be a factor. The second number would be a factor of the first one. Factor of some sort, but I don't know if I can work with that. Can this be like my second solution? I paste it here. Let's do that. In case I get lost. Okay, then the first one I'm gonna clear. Okay, we're gonna redo this. So I can think clearer. Copy this to the second, and also copy the first one over here for the running result. You call it running total, but it's 2 words. That won't fit on the label, the comment. How many times does the second fit into the... Oh! How many times does it fit into the first? Oh. Subtract. Does that subtract from the floor and puts the result in your hand? The result goes into your hands. So just remembering, I think I got it, but we do an 8 and a 3. Okay, so 8 minus 3. Does that go anywhere but my hand? That's 3 minus 8. Oh, I subtract the first. No, I want to subtract the second. 7 and 4. So I subtract the 4 from the 7. No, that's not what I wanted. What is this? Am I reading this wrong? Oh, I have to copy the other thing first. Sorry, I'm stupid. This is already inefficient. I don't really care. Okay. Subtract the second from the first. I can clean this up in a bit. This is how I'm thinking it should work, right? 6 minus 2, 4, okay. But he doesn't put the 4 on the floor, so we're alright. Okay. That's what I wanted to figure out. So if that goes in and it's positive, or it's 0, if it's 0, it does go into the number at least once. So yes, if it's positive or 0, let's have a counter. Okay. If the result is positive or 0, we'll increment a counter that will start at 0. And they already gave us a 0, so that's good. That's good, I like that. 9 can be the counter. Actually, no, we need a thing that's guaranteed to be 0 that we can reset every time. Okay. Let's do this first. Copy from the 0 flag, the dev 0. Put that into the counter to start off, so that'll be resetting it. Okay. Put this here. I'm gonna use all the help I can get. Reset. Alright, that resets the counter. And call this start. Alright, get the first one, put it in result for running total if we need it. I don't know if we need that. Get the second number, put it in the second, get the first one, subtract the second from the first. If this is positive or 0, then we need to increment the counter. If it's negative, then we're done. Okay, so if it's negative, I'm going to take whatever's in the counter and I'm going to output it to the outbox, because that will be our answer. Alright, but if it's positive or 0, then it's not negative, by definition. So we'll increment the counter. And then after that, we need to get a new number. No, we need to subtract again. We subtracted second from the first and bumped the counter, so we have to do that again. Okay, so we do need a running total then. We're going to copy this to result. Alright. And if it's not this, I want to bump the counter. I want to get the second again. This is terrible, terrible inefficient code. That's okay. Get second, and I want to subtract. No, I need to get the results and subtract the second from the results. Again. And then go here. Do this in a loop. So subtract the second number from the first initially, which is going to be in our running total or result. And then if that's positive or 0, then the second number fits into the first number at least one time, so we're going to bump the counter of times it fits into it. And then we're going to subtract second from the result again, and as long as that's positive or 0, then the second number goes into the first another time, so we're incrementing the counter. Okay, otherwise it'll be negative and we're done, and then we can take the counter and put it in the outbox. Okay. And then reset everything. Alright, now this could be cleaned up, obviously, so it's not efficient, but I want to see if it works. So 4 should go into 7 only one time. It's not negative. It goes in once. Subtract it again. It's a -1, which is not right. So we take that and over there. Then we reset the counter. So 3 goes into 6 2 times. I bump the counter. I get a 0, bump the counter. Then we take the count. Wait. Copy from result. Oh, it's a 0 again. So maybe I do need to stop on 0. I keep getting... Oh, I keep subtracting it from... Yeah, I need to stop on 0. That's an infinite loop. We don't want that. I haven't seen what an infinite loop looks like yet, so let's look at that. Yeah, never. I didn't know if the game would be like, you're not gonna stop, so yeah, it doesn't do that. Okay, maybe 99's the limit and then it stops, I would think. Not absolutely sure. Okay. If it is 0, then I guess we're done. I guess. This might end early. If it doesn't, I might have to reverse it a bit, but let's assume... Alright, we'll do negative or 0. Let's see what that looks like. It should be 2, okay. Get a 1. That's not right. Yeah, that's not okay. I just made this wrong. I did this wrong. Get rid of this. Subtract the second from the first, put it in result. If that's 0, let's go here. If that's negative, let's go here. All right, if it's positive, if we're already at result, we can subtract the second one again. Subtract second, copy to result, go here. Do that loopy-doopy. 8 and a 2, which needs to be a 4. That 6 goes in once. We're not bumping the thing, that's my bad. Let's bump the counter first. Goes in once. Oh, that's not good. What do you do? This is a 6. Oh, subtract again. Copy from, so I get the second number back. Or do we need to get the result back and then subtract second from it again? I don't know, this game confuses me. Is that better? It's one time, so add there. And get the result back and subtract that again. It's 1, so we increment the counter. Yes. Okay. And it's negative. Then we put the counter over there. Okay, yeah, that's correct. And then we'll reset those. 2 goes into 9 4 times. So we get a 7 increment, 5 increment, 3 should increment, 1 should increment, negative should go on. Okay, I think that's right. Fails on other possible inputs. Dang it. Alright, which ones? Oh, it fails on 0, I guess? 2 goes into 9 4 times, 2 goes into 8 4 times, 7 goes into 4 0 times, 6 goes into 0 0 times. Okay. So what if something goes into 0? So we're not dividing by 0, but the first number can be 0. Gotcha. Gotcha. Okay. Well, we'll get the first number. If the first number is, the first number is 0, then we'll just take the 0. Okay, they didn't like that one. It's an 8, and 8's not a 0. Saying that doesn't work. I do need the other one up here. Oh no, I got that. I don't know if I should have got that last one. But I guess it was good. Oh yeah, because if we subtract a number from 0, it's going to be negative, so that still works. Okay. Okay. That's a little bit over. That's not too bad. 8 more speed? Okay. Listen, I'm just more speed than they are. They can't handle me. They cannot handle... That was Keanu Reeves, right? They can't handle Keanu Reeves and Sandra Bullock on that bus. Okay, Speed? I think that was that the movie Speed? That was, right? I should know these things. But yeah, they can't handle it. 19 commands. So less commands or less steps. Yeah, I probably could use less commands and less steps. Copy to first and result. Copy to second, get the first one, subtract, put it in result. I guess after we put it in the first one, we could use the first as the running total, right? But what if we did that? This in first. Then this will be copy from first. And to first. Okay, so that took away one step. Small optimization. So I got 18, so 3 more, and then that would also increase more speed. I can delete the second. I can delete this. Track second from the first, leave it in the first for running total. So I'm gonna clear that label. If it's negative, we're done. Otherwise, we bump a counter. Track the second from the first again. Put it in the first. Keep doing that. I don't want to assume they go in at least once, because with the 0 it doesn't, so I don't want to move this down here. Keep that there. Copy from first, subtract second from the first, copy to first. If it's negative, then get the counter and do that. Copy 2 second. I could subtract what I have from the first one. No, if I got it in my hand and I did subtract first, it would subtract that from the one in my hand, and I don't want to do that. I want to do the opposite. What I'm doing now. I guess I could do this before I do that. Check if it's negative. Okay. Yeah, before I even copy it, I can see if what I have in my hand is if we're done yet. If we're not done, then I'll put it back in the running total and I'll bump the counter. Do that. Then I'll track them again. And we don't need this. We'll subtract it immediately. This shouldn't go off in this problem, but we'll see. Check if it's negative. If it's not, copy the result. We have at least one, then subtract it again, and then keep going. That should be less steps. Oh, that is less steps. 3's not negative, so put it there. We have at least one. Subtract it again. Now we're done. Oh, this needs to go above the negative. Yeah. We have a 2. We do it again. That one's negative. And then we put that over there. We'll see what the game thinks of that. It's a little bit better than it was. Oh, 17. 2 less. That was the speed challenge, though. That was the speed challenge. We got one of them. Okay, I can do this in 2 less word things. 2 less instructions. So subtracting the second from the first, right? So the one in my hand minus the one on the ground. So if I did, what happened? What does this look like if I do this? If I get the first number, which is a 7, second one's a 3. Okay, I want to not do that. I want to do 7 minus 3. That's 3 minus 7 if I do that. I do need to do this second from first. Not negative, put it in there, bump the counter. Hit that, subtract that again. I mean, that seems pretty good. Is there any duplicate logic? That's the other thing I need to look for. The subtract second and copy from first are duplicate. But maybe a better loop thing could come from that. Like if I do this, like that, copy from first, subtract if it's negative, otherwise do this and this, and then go back. Yes, yes. And that's 2 less steps. So that would be what the other one is. Bump the counter, subtract the 2, bump the counter, subtract the 2, and we're done. Okay, I think that's what they wanted. I think so. Battery's still good. Not just looking at you to be weird. Battery life's still good. There we go. Beautiful. Might be more steps though. Nope. That's exactly what they wanted. Look at that. See, I can still optimize things sometimes. But that hurt my brain, so I'm gonna go to 3 sort later. Let's do string reverse. Reverse a string in place. Constant time. You can do this. Just do it on a whiteboard in 10 minutes or less. Explain what we're doing. And then you can get the job at Fang. Ole? Yeah, ole? Yado uoi era uo. No, he said hello. How are you doing? Or whatever. How are you today? Haha, haha. Okay, no, seriously. He was speaking some kind of pig Latin. A little bit. Reach 0 terminated string in the inbox. I should hydrate as well. Is there what you can do timers in JavaScript, right? So I could set a timer on my chatbot for an hour or whatever, 30 minutes. Every 30 minutes it goes, hey, you should drink some water. I should probably, that'd be good. That's a good idea. Self. Might do that. Yeah, I did a timer in my, I did a timer for one of my games. Snake. My little JavaScript snake, not on the channel where I did assembly, but on like a portfolio website that I don't have anymore. I did a timer in that. I'll dig up that code. You can do timers. I think probably easier nowadays because that was a couple years ago when I did that. String reverse has nothing to do with this game. It's just, you know, thought about it. For each 0 terminated string, reverse it and put the result in the outbox. Repeat. I give you a lot just in case. So I'm gonna assume no string is going to be greater than 13 or 14, including this. There's 15 boxes. And we have a 0. They give us a 0 for a reason as well. Excuse me. For each 0 terminated string, reverse it and put the result in the outbox. And then repeat. Reverse the string. So we need to keep going until we get a 0. Okay. I'm gonna be bold and assume strings will not be longer than 14 long. So I'm going to copy from 14 and put it into 13. So that'll start as a 0 every time. I can call it count. I don't know the right name for this. I'll call it counter. Counter again. It's fine. Counter without the strike. Trying to resist the urge to go terrorists win, but you know. Fairly obvious reference. Logic. Okay, so we're gonna start the counter at 0 every time. That's what we're gonna do. We're gonna do that every time up here. Every time. This will be our reset point. Our initial stuff, our reset point. Okay. For the next string. So start the counter at 0. Get the inbox. Okay, copy to wherever the counter's pointing to, which at first will be 0, so it'll be up here. You see where I'm going with this? And then we're gonna bump that number. And then we're gonna get the next thing. We don't have to do that though, we can do a loop. And then we'll check if it's at 0. If it's at 0, we want to do them in reverse order, so we'll go down here. Get out of here. Put this here. Alright, this will be reversing the strings. Put reverse. I write in a downward slant because I'm pessimistic. That's what old grade school teachers told me. I've always written that way. Other people wrote up, and I was like, what are you doing? You can't reach the ceiling, dude. Why would you do that? But not everyone was tall in grade school. Some of us were later bloomers, but you know. Okay, yeah, since we bump the counter every time, that keeps a count of how many letters, how many characters are in our string. You see? So then we copy from wherever the counter's pointing to, and we put that in the outbox. And then we decrement the counter. So that'll go in reverse order. So if we go up to like 10, the next item's a 0, we're gonna start copying. We do need to store it though, don't we? If we pick up a 0, then yeah, if we pick up a 0, then we're done. Okay, I don't think we have to include the 0 in the outbox. I'm assuming we don't. It'll tell us if we're wrong, though. Okay, but if we put in, like an L, L is not a 0. So we'll copy to the address 0, the L, bump the counter to 1, pick up the O, put it in 1, bump it to 2, pick up the G, put it in 2, okay. We pick up the 0, then we want to reverse it. We need to go down here to reverse. Let's get rid of that for now. Alright, get a 0, then we want to reverse it. So we're taking from the counter to the outbox, bumping down the counter to go down to 0. Okay, the counter can go negative, I think. I don't think that'll be an error. I mean, a negative address would be an error, but the counter itself being negative, I don't think would be bad. Because then we could do a check if negative, we'd have done everything down to 0 and put it in the outbox. So then we're done. Or I could put. No, yeah, we'll have to jump if negative. Yeah. If negative, we're done. So we want to reset and get the next number. We'll do this. Reset the counter to 0, get the next number. Or the next string. Start getting the next string. Okay. But if we're not negative, I want to keep doing this. Okay. Let's see if that is sound logic or not. You set the counter to 0, put the L into there. Counter's at 1. The next item, put it in the 1. Bump it to 2. And then we get a 0, so then we want to put the string in the outbox in reverse order. With an empty tile. Oh, because 5 is empty. Oh, so I bumped it one too many. Okay. Okay. I mean, I could bump it down to begin with on reverse. That seems like a waste, but I could do that. I could do that. No. Which goes to on. That's a 0. It'd be 1. So when we copy from that address, put it in the outbox, that's down to 0. It's not negative yet. Get the next one, put it over there. Now it's negative, then we jump if negative to reset for the next string. If we get a string that's less than the previous, well, no, this should still work. It doesn't matter. I was gonna say if we got like a 2-letter string and then a 1-letter string, technically, then we would still pick up the second letter and it wouldn't be right, but I don't think so with how we're handling the counter. I don't think that'll happen. So I think we're okay. So we're spelling time. All right, then I want to see you take it in reverse order. I think we're good here. Keep on clicking. Yeah. That one's not too bad. So if that interviewer tells you to reverse a string, and you only get like 10 bytes to do it, you tell that guy, okay. And he says, what language do you want to do? You tell that man, assembly. And you put your foot down and you be assertive. And tell him, I can do it in assembly. Only using indirect addressing, copy to and from, and add and subtract, or increment decrement. You tell him, and it's right, you can do that. And he's gonna be like, oh, this guy knows more than me. And he's gonna feel threatened. It's gonna be great. He's 13, okay. Is there a way I can use 2 less commands? Is there a way? Probably, because I felt like this was a waste, so that's 1 less. See this? This is duplicate, right? If this is duplicate, that means our loop can probably be a little bit better. Which means I can remove this and put this down here. Although I don't know if that's guaranteed to be right, and it's not. Can't jump if negative if you have empty hands. All right. Wait, so where did this fail? Sorry, I didn't mean to. I meant to do this. I meant to step, not finish the thing. Grab the 0. Lower the counter. Get the counter, put it in the outbox. Oh, because I put it in the outbox first. Oh, okay. We'll do that. Put it there. Right? Yes. Copy from the counter. It's 0, so we still need 1. It's not negative. I got an achievement, glorious failure out of bounds. That's, yep, tile with address -1 doesn't exist. Oh, I knew that would happen. I program in C, I know how that happens. You know. Oh, bump minus counter, so I'd want to put this here. We're just gonna move it around, this is debugging. now it's negative, and we want to disregard it. Reset the counter, get the next string. Okay. There we go. So that was, I think, one less step, right? Yes, but we can do it in one less, even more. That was more, that's fine. We're going for size, not speed, because we did speed. So I can get rid of one of these things, or rewrite it so it's better, and we don't use one of them. Okay. It's not 0. Start reversing. Oh, if it is 0, yeah, we want to reverse it. If it's not 0, copy to the address that the counter's pointing to. And bump the counter. Well, I've copied 2 twice here, you see. But what happens... I do need to do this before I bump. The inbox for starting letter of the string. Or next letter of the string. It's not 0. Well, we could assume right off the bat that we have at least one letter. And then if it's 0, we're going to decrement this anyway. So if we assume off the bat we have a letter, we can do that. And then get rid of that one. Right? So this will still start it at 0. And your nose will itch. And then we can assume it's at least 1. And then if we pick it up and it's 0, and there is not even one letter, it's an empty string, then we're going to decrement it anyway to 0. And then, but I don't think we have any one-letter strings, so that would not work for that. But this might be okay for this problem. No. No, he puts it in the counter. Interesting. Inbox. Okay. From 14 to the counter, yes. Can bump this first. We do need to pick that up. If it's not 0, need to put it there. Do need to copy to counter. Dang it. That's just as many steps. That's not less. Right? I don't think it was. That's still 12 and not 11. Right? Yeah. 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 Okay. Okay. I mean, it'd be good if I didn't have to bump the counter one too many times, right? Is there a way I can get around doing that? Yeah, I thought these were the same. Yeah, I didn't see the brackets. It's hard to see. I think that's about as good as it can get. It's not a 0, we increment the counter, and we go down. Look at the W. Copy it to 0. This is a 1. H. Copy to 1. It's a 2. Copy to 2. It's a 3. N. Copy to 3. That's a 4. Hit the inbox. If it's a 0. And then if I do this, if I increment after, yeah, the counter's always going to be 1 extra. Dang 0-based addressing. It's always going to be 1 extra than we need, so we'll probably always need a minus bump there. Let's get it after when. Okay. Yeah. It's always going to be 1 extra. If we took that out and I tried to copy from this, it would be in 5 and it wouldn't be valid, so it would error. I don't want that. Don't want any errors there. If I did that, it would start at 1. Or we can do that. So that would be the same number of steps, wouldn't it? If it went to reverse. And copy from the counter. Yeah, from the counter to the outbox. Bump the counter. Go to 3. Not negative. This would be the same number of steps though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I can do this though somehow. Here we'll put it there. Yeah, that would be... That works the same, right? It just puts it there. Oh no, I put... Never mind. Yeah, that doesn't. I bumped the counter, but it copies the thing in my hand. Yeah, I do not want to do that. That's why we did that. Okay, I might just call this a, you know, a draw here. I did do what it wanted. Although I guess instead of this being, well, if it's negative, we just have to get it back up to 0, so we don't necessarily need to even go up there. We'd have to go up here somewhere, but it'd have to be like a bump. Well, we could use 14 as a counter, maybe. Could we do that? Copy to that, and then bump that. And then from that, bump minus. What happens if we do that? And then when that's negative, we gotta go back up. It's gonna look bad, so I don't know if it'll work. If that's negative, I need to bump it back to 0 and then go to the start. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. No, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's still 12 though. But does that work as an alternate? No, that's empty. Copy to 0, increment. E goes to 1, R goes to 2, increment to 3, or well, increment to 0. Bump minus. About that. That's closer to what I want, but that's not 11 steps. I know I'm spending a while on this, but it's interesting. It's still 12, okay. So I should be able to do this in one less numbered thing here, one less instruction, one less step. Battery's still good, okay. Yeah. So negative, I do 14, and I go back to the start. Okay, so instead, since I'm bumping plus, I can put here, and then this will jump to the start. I don't need that. Or that. Right? H, bump it. E, R, 0. Subtract, get it from there. Get the E, get the H. Bump its negative. Make it back 0. And then get the next string. Yeah. That's looking good. Oh, it keeps it numbered on the side. Hey, you know, I haven't noticed that the whole time I've been playing this. It's 10 steps. It's numbered on the side. That's better than 11, actually. 10 or fewer. Look at that. Beautiful. Look how many other people did that. That's got to be like one of the best solutions. I like that. That's a beautiful solution. I like that. It's elegant. Okay. I don't like 3 sort. Let's do this in the coffee break and then maybe I'll look at 3 sort. Inventory report. The very boring sequel to minority report. Inventory check. Accounting verification. Surprise audit. The IRS is here. These are a few of my favorite things, so let's get started. She was trying to be funny. She must be, yeah. Compliance officer. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Matching items, but they're letters. They did letters on purpose and not numbers, so it wouldn't be readily apparent. Because if you did numbers, you could subtract, and if it was 0, they're equal. So you could keep re-getting the first thing and checking against all the boxes, and if it was 0, then you're good. I don't think you can subtract letters, because I don't think they convert them to, you know, ASCII representations, but we can find out. The first one's a B. What happens if we subtract from this? Oh, that is how you do it. Okay. Okay. Okay, we can do that. Subtract B from B at 0. Nice. So we have to loop through all of these. So I could have a thing like I did last time. I could have a counter. Count. I'll just call it count. I'll have count over here. So this is automatically inefficient because I'm doing this to start off, but that's okay. We'll do this to start off. So count will be initialized to 0. We'll get our first letter. We got to loop through all of these up to 0. We can stop at 0, which is kind of why they did this in order like this. That makes sense. The one that we pick up in our hand, let's also copy this over here. And we call this copy. Or save or something. I'll call it copy. So our letter we're going to copy to the floor. And we need to check it against all of these. So let's subtract the copy letter from our count address. It'll subtract it from the thing at 0 to start off. Okay, and if that is 0, then we want to put the total number of matching items. Okay, I'm gonna make it. Okay, I'm gonna make another label. This will be number matching. Number match. Or I can fit ing. Number matching. Okay. Let's initialize all those puppies to 0. Okay, if 0, I'm gonna bump that number up. Right? Right. Although this will count this as 0, so I'm not sure I want to do that. So instead of subbing count, I could copy from count. If that's a 0, then we need to get the next inbox. This one's a 0. I need to go up here for the next number. Yes, okay. Because we've gotten to the end of this loop that we want to check, but if we're still in the loop, pick up the number here that it's addressing, or the letter that it's addressing. I want to subtract that from the copy. Copy number. Then if that's 0, I want to bump the matching number. But what if it's not 0? Then they don't match. And I want to increment the count. Increment the count, and then go here in a loop. Yes. So we're going to initialize these things to 0. Initialize the count and the matching to 0. We're going to take our first letter, which is A. We're going to put that into copy. Then we're going to get the letter referenced by count, which will start at 0, so it'll be this B. Subtract that from the copy, which is A. They won't be equal. B is one more, so probably be -1. They won't be equal, so we're going to bump the count and then go back. So we'll be on number 1. Okay, then we'll copy from that number 1. From the reference. And we'll subtract it from the copy. That's an A, so that should be 0. So then we'll bump the number that's matching. And then we'll bump the count again, and then we'll go back and get the next one. Okay, so that'll go through these, I think. And then if it's 0, count is 14, and it's 0, we want to get the next inbox. Okay. Although realistically, let's just put this down here and make it even more confusing. I want to output matching. And then I want to get the next one. Actually, I want to do this again. For the next one. Okay. I think that might be alright. So we initialize those to 0. We get the A, put it in copy. Get whatever number that count's pointing to, so get the B, whatever letter it is. Subtract it from the copy. That's 1. So they're not equal, which is the important part. So we bump the count, get the next one. They are equal, so we bump the number matching. And then we go to the next one. So this should be equal, so we increment matching again. Okay. Let's just check this again. We get this 0. Okay. Output the number matching. I'm not outputting the number matching. I'm not copying from. Copy from matching. Put it on the outbox. Alright. There we go. So on this 0, number matching is 2. There's 2 C's in this whole array. And we got it. And we initialize those back to 0 and use the X now. Okay. So I think that's right. This could probably definitely be simplified a little bit though. But that should satisfy the problem. Should, air quotes. It's pretty fun. I like this game. I like it. Some interesting problemos. This is like LeetCode Lite. This is a LeetCode Easy. Limited assembly. Basically is kind of like, yeah, that or HackerRank. A little bit, because they give you size or speed after. Oh, size we got. Ooh, it could take less steps. Okay. Is there anything obvious we could do for less overall number of steps, which is 16 times however many, things. Up to this. We could even try and look at, well, I'm not going to. You could try and look at it from an algorithmic perspective. So each letter we have to go at least up to the whole array, which would be n for the size of the array, assuming we have to check them all. If we have to check them all, that's kind of, is that n factorial? No. That's a big number. N squared maybe, because we have to check 1 against every single one in the array. That might be quadratic or more. I don't remember. I'm trying to learn Big O and algorithms, but I can't conflate the two together at the moment. That's alright. That is okay. I do that? You know what I could do? Is bump the number matching and bump the count. It's not 0. Track copy from it. If that's 0, then it does match. If it's not 0, is this not what I had before? Yeah, 16. That's just what I had before, I think. I wanted to make it better. We do need at least these 3 for the overall loop. If we use this 0 as a counter, what would change? This count would be this. So if this one referred to itself, I would pick itself up again. It wouldn't be a 0 though at this point. So I'd probably have to subtract itself from itself. And check if that result is 0, then I'm on this one. Oh, this is probably not a good solution. Well, subtracting itself from itself will always be 0. Oh, never mind. Never mind. Undos are nice. How would I simplify this? Less overall steps. Hit the number, put it to copy. I'm gonna have to get this and go through every one. That's why the overall number I think was high. Be 4 times 14 at minimum. 14 4 times. Yeah, that is the game music. Sometimes I have, like, you know, music going in the background that sounds like this, so I was like, the game knows what I listen to? That's weird. From there, subtract the copy. If it's 0, then they match. Bump the matching. I mean, and bump the count, yeah. If it's not 0, then we want to bump the count. Copy from that. If it is 0, we want to bump the matching. And the count. Yeah, it's still 16. So that's just the same as it was, right? I'm pretty sure. That's the same solution that I did have. They needed even faster speed. They need ludicrous speed or maybe plaid. You can't sub with mix operands. Ooh. So this is not right. It's even worse. So copy. I don't copy that to copy, do I? Maybe I was. Oh. Copy from count. Track the copy. If so, then it matches. Increase matching. Otherwise, bump the count. This is what I had before, and then put jump back up to there. Although that says 15. That's not right, right? It's 2. 14. No. Yeah, because we need a 0 here from the count to know when we're done. Yep, that's a jump of 0. And then we output. Yep, that's what that was. That's 16 though. I don't know how to make this smaller. I don't really care. I'm gonna go through it. Well, actually, I already solved it. Okay, I'm not gonna deal with that right now. It's a cop out. Sorry. I said coffee break. I'm out of my coffee.
Where's Carol?
Voice acting.
Oh my god.
I think Carol took a tumble
This
there.
coffee is amazing. Back to work, ladies.
Okay. Coffee time. Oh.
Breaking.
Ooh.
Previous reports of machine army evaluate to false.
Mhm,
Everything
sure they
equals
do.
100% fine.
Mhm.
Whether within pleasant tolerance parameters or human skin layer.
Okay, that's
You're
good.
all going to be fine.
I, for one, welcome our robot overlords. The other cutscenes, the power went out. At coffee time, the power went out, and then they need better morale. The robots basically surrounded the city after they went to the beach. And then I guess everyone's been taken over by robots except people. That's why they have robots here. Except people in my building for some reason. They just keep their coffee. I guess we can, you know, satiate the populace with caffeine and they won't need to worry about it. That sounds about right. Sounds about right. Is this 3-sort one like stupid hard? Let's find out. We rank all our employees here, from worst performing all the way up to best performing. Where do you rank? Let's give it some thought while we complete this assignment. Analyze it right now. For each 3 things in the inbox, send them to the outbox in order from smallest to largest. Oh. This could be long. They already put this here, that's helpful. Copy them to the first 3. In order from smallest to largest. Okay, what if they're equal? I don't think we'll have any that are equal. Otherwise we wouldn't be able to rank them well. Well, we could, but maybe we will have some that are equal, I don't know. But let's start off here. Let's do largest. We'll do middle. We'll do smallest. Smallest, middle, largest. Okay, we'll copy them to 1, 2, and 3. We gotta compare these. You gotta compare them all against each other, which I think is... Is that factorial? No, 3 factorial would be 6. So maybe, it might be a factorial amount of combos that we need to do. That's what permutations is, right? We have to try out each one. So 1 compared to, well, 1 compared to 2 and 3. 2 compared to 1 and 3. And 3 compared to 1 and 2. We have to at least do all those. That's 3 times 2, which is 6. So I think it is factorial, amount of times, at minimum. Well, we could start off with 1. Well, we end with 3, though. It doesn't matter. If we start off with 1, say... So to compare it to the other 2... we can subtract 2 from 1, right? Or does that subtract 1 from 2? Subtract 2 from 1, okay. If it's not 0 and it's not negative, then 1 is larger than 2. Yes. It's positive. If it's not 0 and not negative. If it is 0, they're equal. I'm hoping they don't have any... Oh, they have zeros. That's okay. Let's just put this right here. Oh, not 0, negative. If it's not 0 and it's not negative, then it's positive. So 1 would be larger than 2 at this point. So let's just put this here. Let's do 1 greater than 2, or 2 greater than, or 2 less than 1. 1 greater than 2. So at a minimum, or like, yeah, by default here, I would then copy from 1 and put it in the largest, or in the middle, and then 2 would be in the one below that. So 2 would then be the middle here. We don't have smallest though. But we could do that by default. So if I reverse this, just to save a thing here, copy from 1, copy to largest, and then subtract. So subtract 1 from 3. And if it's negative, then 1 is larger. So 3 would go into... I'd have to compare 3 to 2. So 1 is largest at this point though, if I do this. So let's do this. 1. One is largest at this point. We know that for a fact. So then I have to compare 3 to 2. Yes. So we'll subtract 2 from 3. If it's negative, then 2 is larger than 3. So this would mean 2 is the mid. Oh, that's a bad D. Well, I could just do this. 2 mid, 3 small, or small. 3 is small. So 2 would already be in the middle at this point, so I would just move 3, well, if it went in our single branch here. Move 3, the smallest. I know this is gonna be super long and terrible, but I'm like, you know, loop unrolling right now. Send them to the outbox in order from smallest to largest. Oh, that's good. And I would copy from middle to outbox, then I would copy from largest to outbox. And then I would go and get the next 3. Okay, but that's not guaranteed to always be the case. In this case it is, 961. In the second one it's not. The second scenario here will be reversed. I'm assuming we won't have a 0, so we'll put that in later if we need to, but... I'll put a bunch of comments here. 1 minus 2. Subtract 2 from 1. It's negative 1's greater than 2. Or if it's not negative, then possibly 2 is greater than 1. Oh my god, I can't draw with the mouse. Need to slow down. Two is greater than 1. Copy from 2. Put it in the largest. Copy from 1. Put it in the middle. This is a terrible way to do this. I could probably do this with loops and abstracting logic. But oh well. Well, we don't have to do this yet, actually. We can do this. 1 minus 2. So 1 is greater than 2. We know that here. Let's not do this yet. Let's do that. So get 1, subtract 2. If it's negative, 1 is greater than 2. So we get 1 and subtract 3. So if that's negative, then 1 is the largest. And then we get 3, subtract 2. If that's negative, then 2 mid, 3 small. So then we would get 3, go to the outbox, 2, go to the outbox, 1, go to the outbox. Okay. But if 2 is greater than 1, we want to copy from 2 and subtract 3. Okay, and if that's negative, then 3 is larger. And if 3 is larger than 2 and 2 is larger than 1, then we're good. I would have, at this point, we'll do 3. Alright, we'll do 3 is the largest. 2 is middle. 1 is small. Three, 2, 1. Then I would jump and get the other ones. Okay. It's one situation here. That's 3, 2, 1 here. This is 3, 2, 1. That's 2 mid 3. Oh, I want to do smallest to largest. Yeah, this needs to be 1. I need to do that. Okay, let's do one at a time. So let's do the first one. That'll be in order. It'll be 9, 6, 1. Smallest to largest will be 3, 2, 1. I have that down here. The second one, smallest to largest, will be the opposite. I'll at least get past those two. Let's see if that works out though, before I go any further. That needs the opposite. I consider it to be the opposite. 8, 4, 2. Get 1, subtract 2. It's a 4, so 1 is larger. Oh, this is reversed. Oh, this is reversed. Okay, yeah. 2 is larger than 1 if it's negative. That's reversed. Two sub 3. I need to go 3, 2, 1 here. This is, yeah, it's reversed. Do 1 equals L, 2 equals M, 3 equals S. Large, middle, small. Okay. Second one we need to check. Two's greater than 1. So 1, 3. Negative 3 is greater than 1. Copy from 2, subtract 3. Positive 2 is greater if it's negative 3 is greater. But we don't do anything for positives here. But negative 3 would be greater than 2. Be greater than 1. Oh, my brain's fading fast. At least I get the first case. Alright. This, 3, 2, 1, we'll copy for 1. Alright, outbox. 2 outbox. And 3 and outbox. don't like where I'm going with this. Alright, let's fill in some other cases here. If 1's greater than 2, subtract 3 from 2. In this case, subtract 2 from 1. It's negative 1's greater. No, 2's greater. Otherwise 1 is greater. Subtract 3 from 2. If it's negative 3 is greater. If it's not, who's greater? Three's greater, 3's the smallest. Otherwise 2's greater than 3. 1's greater than 2. 2's greater than 3. Be 3. 3 is the smallest again. 3 equals S. Right? 3 minus 2. Negative 3 is greater, otherwise 2 is greater. 1's greater than 2. It'd be the same thing here, wouldn't it? Oh, I don't know what I'm doing. That's not necessarily true. They put a negative in to screw me over. Well, 2 is greater than 1. Not negative. Yeah. Subtract 3 from 2. If it's negative 3 is greater. If not, then 2 is greater than 3. So if 2 is greater than 3, and 2 is greater than 1, 2 would be the largest. 1 would be the smallest. I think this is like a really common like programming thing that I'm just not seeing. I'm doing it all manually, which is not great, but that's okay. Now, 2 is the largest. So 1 and then 3. And then 2. And then jump to the top. I don't care as long as it works, you know what I mean? We have the first one at least. Second one, I think we also have. Okay, then this one. 2 is greater than 1. Not negative. 2 is greater than 3, so we didn't do 1. Oh, what if it's 0? Ah, you freaking put zeros in there. Oh. Terrible. Messing up my plans. change this. We'll do compare. And I'll just do plus. Compare 1 and 2. Back 2 from 1. Negatives 2 is greater. How do we know if it's a 0 though? I don't like this one. I mean, I can save it and then come back to it. Or just leave. I've probably been on this one for like an hour. It feels like it. Been live for 2 hours, huh? Yeah, did not do too much this stream so far. Well, we can delete things and start over again. Let's do that. Okay. Yeah, let's just, let's get a clean slate right here. Right? Battery's still good in box 1, 2, 3. Okay. We have the 3 in our hands at the moment too, so we could save a thing by just directly comparing 3 first. So let's compare 3 and 1. So let's subtract 1 from 3. If it's positive, then 1 is larger. Okay, if it's negative, 3 is larger. Or one of them 0. Well, if it's positive, one of them could be 0 as well, unfortunately. I'll put that under here. Check if 0. Okay, but if 1's larger than 3, then we need to compare. One and 2. We'll subtract 2 from 1. And if it's positive, 1 is the largest. Or do we need to do the other ones too? Crap. Should be able to do this in 2 comparisons, but do I need 3 comparisons? No, I compare 3 and 2. Yeah. Yeah, because we already know 1's bigger than 3. Compare 3 and 2, yes. Subtract 2 from 3. And if that's positive, 3 is larger than 2. If 3 is larger than 2, then 3 is the biggest. Who's in the middle? 1 is the smallest. No. 1's bigger than 3, 3's bigger than 2. 1's bigger than 3. 3's bigger than 2. 2 is the smallest. Oh, but if it's negative, 2's bigger than 3. Man, I don't know what I'm doing anymore. Go ahead. Check 1 from 3. If it's negative, 3 is larger. Okay, if it's positive, 1 is larger. So then we compare 3 and 2. Subtract 2 from 3. If it's negative, 2 is larger. If it's positive, 3 is larger. So 1 larger than 3 larger than 2. Yeah, that's right. It's negative 2 is larger than 3 at this point. 1 larger than 2 larger than 3. Okay. Okay, largest, middle, smallest, largest, middle, smallest. Okay. We have 2 out of the 9 combinations. I will say no matter what we do here, 1 is the largest. So that might come into play, where we always output 1 last. So that would be something. Output 1 last, or 1 largest, or whatever. Output 1 last here. Alright, otherwise we have 3 greater than 1. So I still have to compare 1 and 2. Let's subtract 2 from 1. Okay. And if that's positive, then 1 is larger than 2. Alright, so if 3 is larger than 1, and 1 larger than 2, then it's 3. Yeah. So that would make 3 is the largest. 3 is larger than 1, larger than 2. Okay, if it's negative, then 2 is bigger than 1. So 3 is the largest, then 2 is the middle, then 1 is the smallest. Alright. Put the thing down here, open another thing in here. This will go down. Output 3 last. Okay. So other conditions. 1, 2, 3, 4. It'll only be 4. I need like 2 more conditions, or 2 more end conditions, I'm pretty sure. I guess if they're smaller, yeah. Compare 1 to 3. Or 3 and 1. Subtract 1 from 3 if it's negative. It could be 0 as well. I'm not considering 0 cases. I'll put this in for now. Copy from 3 to the outbox. I'll go to the start. Let's do 2 outbox, 3 outbox, and then we'll go and put 1 last. Otherwise, if it's this one, copy from 3, to the outbox. 2 to the outbox, and do 1. Okay, but which ones aren't covered here? Two and then 1. This is 1 and then 2. Okay, but it won't work for like zeros, but let's see where this goes. The negative. Wait. Copy to 3. Subtract 1 from 3. Oh, it's negative. That would mean 1. God damn it. Why do I keep reversing these? I mean, 1's greater than 3. Okay. Well, I mean, this stuff will work. I'm just doing it very badly right now. Keep reversing these in my head. It's not working out. Not working out so well. I'll only be on this problem for 5 hours. It's okay. Need more water. That's the issue. Need to hydrate that brain station. And I do sub 1. I subtract 3 from 1. No, I subtract 1 from 3. I guess I thought that was 3 minus 1. Okay. So subtract 1 from 3. It's negative. 1 is greater. I need to compare 3 and 2. Interactive debugging. Debug-driven development. So if that's negative, three, subtract 2. 2 is larger. It'd be 1, 3, 2 for this one. Just have to reverse these, because 2 would be larger. So 1, then 3. And this would be 2. What did you want, dude? Subtract 2. We get the 3. Subtract the 2. It's negative. It means the 2 is larger. So the 3 is the smallest in that case? One is greater than 3. Oh, 1 will be the largest. God, I'm an idiot. I'm just gonna do the edge case. I'm gonna do whatever cases the problem gives me and then see if we get there in the end. I'm gonna code for the problem set, which is not what you're not what you're supposed to do. No, I need 3. Yeah, I even wrote it down. 2. And then this one's 1. Oh, this is terrible. Okay. Eventually I'll get through one of the first problem set first. First 3 numbers. I'm gonna put a 2. 1 last. I even wrote down the 1. Okay, but that's okay. That's a 3. Subtract 1 from 3. It's positive, so 3 is larger. Okay. Copy from 1, subtract 2, negative. So 2 is larger. Okay. One is smallest. One, two, three. Get the next 3. Subtract 2. It's negative. 2 is larger. The 1 is the smallest. Then 2. Then 3. The next 3. Which we have 0. Oh, this is gonna be bad. Three is a negative 2. Subtract a 0 from a negative 2, so it's still negative. That would mean 1 is larger than 3. Compare 3, subtract the 2, it's negative 8. That's gonna say the 3 is larger in this one, isn't it? No, I'll say 3 is smallest. And then the 2. Interesting. But they wanted the 1. Okay. Do I have to account for negatives on all these as well? That would be annoying. We won't have to compare against 0, I don't think. But if a number is 0, we could do a jump. Let's do this. If 3 is a 0, do separate 0 tests now? I don't want to do that. The other ones could be 0s as well. I don't know how to do this. I'm gonna... Does this save if I leave? Let's find out. This is like some simple algorithm that I don't understand. It saves if I leave. Okay. I'll do that. Maybe on my own time. I don't want to waste 3 hours not doing one thing and not getting it done, you know? It doesn't make for good content. Hey, Chisel. What's the meaning of this? Management is attempting to reduce bandwidth by removing all vowels from every word. Good luck. Except vowels, so I have to check. Okay, but they put the vowels on the floor. Send everything from the inbox to the outbox except for vowels. We need to check probably these in order. If the letter equals one of these letters, then it's a vowel, so we don't send it. If it doesn't equal any of them, then we will send it to the outbox. That's what we'll do. So first of all, let's set a 0, an initial count. All right. We'll subtract what's in our hand from that. Or will we subtract that from what's in our hand? Yeah. Yeah, same thing, doesn't matter. Okay, and then if that's 0, then it is a vowel. And we want to reset and get the next one. If it's not 0, then we want to bump that. And check the next one. So let's see, for this that would be an N, or an H. That's an N in Ruski, but we're not speaking that. It's an H. Subtract this from that. It's not 0. So increment to 1. Subtract that. Oh, we gotta reset, don't we? Yeah, okay. Let's do this. Do what we did the other time. That's terrible. P, Y, copy. Count or index, we'll name this count. So reset count to 0. Get a letter. Copy it. Subtract the letter from the pointer that count's pointing to, so 0. If it's 0, then it is a vowel, so we want to get a new one. Alright, if it's not a vowel so far, we want to bump count. And then copy from copy to reset that. And then check against the next one. Okay, we'll do that. But we have to check when we reached a 0 over here. So I could reverse this. Instead of subbing from count, I could copy from count. Subtract the copy. Should be reversed, but that would do the same thing. 0 would be a vowel. Not 0. We would bump count. And get the copy again. Okay. No, don't get the copy again. We bump the count. Copy from the count. If that's a 0, then we need to get the next one. Or no. If that's a 0, then we've had something that's not a vowel, so we want to send it on. Yeah. Go to the outbox, and then we'll jump back. There we go. H, those are different. Yeah, subtract the copy. Not as... I guess we would do or if negative. No, I guess if they're not equal, we want to keep going. No, that was right. Never mind. But they're not equal, so we'll check the next one. Check the next one. Check the next one. Those are equal. We don't want it, it's a vowel. Reset the count. None of these are going to be equal. Count is a 0. So we're done, and it's not a vowel. We want to send that on. Oh, we copied the L. Copy from the copy. There we go. Send the copy out there. All right. Yep. Copied the copy. So we got the 0, we got the copy, then we're sending that. There we go. If it equals 1, then we're getting the next letter. This is an I. It checks that, just gets the rest. Okay, yeah, we're good. I'm just too stupid for that 3-sort problem, man. Like, dang. That was bad. The battery's starting to go down on the camera, so I think I'll probably go another 30 to 45 minutes, or if the battery dies, I'll end it early, but I'll go at least another half hour. The battery should be okay for that. We did get the size challenge. And we got the speed challenge. Okay, well that's what they wanted, so we're good. Could probably optimize that, but I'm just gonna, in order to feel better about myself, I'm just gonna take the right path right now. I'll do the other ones later. And duplicate removal. Oh wow, now the building's gone. You're fired! Haha, just kidding. But I do have a note here from your other supervisor. She's out sick today, but she says it's time to eliminate inefficiencies. Are the robots taking over the company from the inside? And that's it. They might be. Is this game an allegory to people's lives, people's jobs being taken over by automation and robotics? Machine learning, AI? Maybe. Don't read into it too much. Everything from the inbox to the outbox, unless you've seen the same value before, discard any duplicates. Unless you've seen the same one before. So these could be repeated, any of them could be repeated. Only send the first occurrence of a letter to the outbox. Okay. Okay, I would stop here. Let's hope we don't have too many letters. I want to put a thing, oh, I have to tap it for it, yeah. Let's hold an overall count of letters. Count. Let's set that to 0 to start off. Okay, get the first one. Copy it to wherever this address is pointing. If it's not already seen, we don't want to compare against any blank ones either, because we'll get errors from that. But count will tell us how many are filled out if we use it. Or I guess we could increment this one to start off and not use a count. This could be 14 could be the count. At minimum, we would make it 1, because we have a D. I don't know. Copy to where that's pointing to? If it's not already filled. So I want to loop from count down to like 0, probably, to reset count to 0. But I have to do that in order to check these. It picks up the D. I'm going to increment that to 1. Get that. Put it there. Well, at the very least, I want to send the first one on. Let's send the first one on first. Okay. The next letter will be E. Have a copy or a save area. Alright, subtract it from where count is pointing to, which will be 1. Maybe not. Copy the D to the 0, output it. Count will be 1. That's where the D is. I'm gonna save it first. This will be empty, so this is gonna error. Okay, what if I have somewhere down here? Or if I do this later, but... Read down to 0? Do we want to add till we stop at the 0? Or do we want to, like, read down to where we get to 0? We need to use something as a reference, of course. I wouldn't have these tiles otherwise. Man, these are hard. It's hard for my small pea brain. Ugh. Très difficile. Très difficile. Okay. Or they're probably très facile, but I am idiota. How do we tell if we've seen the same one before? I want to store each one, but I don't want to store it if it's already been there. So how do I do that? I can save it off to begin with. I have to avoid checking an empty space because I'll get an error if anything is ever empty. I could initialize everything to 0, so that we have something to start off with. Which is kind of dumb, but maybe we should do that. Although if I got a 0, that would mess up. We could take that stupid approach. We could do that. But I'd have to go up to like this. Copy from count to where it's referencing, and then bump it. If we got up to here, it'd be too many though. Be 0 to itself. We couldn't go past that. No, I don't need to fill it. I was itchy. I don't think I need to pre-fill everything with values. I think there's a better way. Gotta be a better way. Gotta be some simple, elegant way I'm not seeing. Let's give him an example. Okay. Yes, I'm scared of her too. Okay. $17, 167. Man, they don't give me a hint. And tell me what the output should be, which is nice. Okay, I guess we'll just go in order until I get the light somehow. Somehow. This will fill out the board repeatedly. Alright. So, there's not too many letters. So I'm gonna put it down here, bump the count. Get another one. Let's copy count somewhere, yeah, let's do that. Do that here. Save the count in 13. Lucky number 13. So this will start at 0. We could start the first one at 0 as well. Maybe that would work too. Let's do this. Let's subtract where it's referencing. Whatever we get from the inbox. But I need to copy that. I'll copy there for, yeah, I'll do what I was doing before. Save. Copy to save, subtract from where this is pointing. If it's 0, we've seen it before. Look at the next one. If it's not 0, but we don't, if it's not 0, I want to store it, but I have to check every single one to see if we've already gotten one before. That's the issue. Bump the count. I want to make another count, a count 2. Two's bad. It's a little better. Initialize. This to 0, this to 0. Save off current letter. Subtract it from where this is pointing to. Call this like array or pointer or something. Oh, pointer. Okay. Subtract where that's pointing to. We initialized to 0. If it is 0, we've seen it before. If it's not 0, I could try storing it there. bumping the pointer. The next one, so let's see. That does that. Can't sell with mixed operands. That's lame. Okay, so they don't want you to do that though. That narrows it down a little bit. A little bit. Can't do a sub. Let's do this first. Inbox. Copy to where that's pointing, just to have one to start off. And then we'll get another inbox. Copy that to save. Subtract it from where this is pointing. That's pointing. If those are equal, and we've seen it before, and get another one. If it's not equal, then we can store it. Depends where the pointer is. Copies of the current max number, which is where the pointer is. What I want it to be. I need like a separate counter somehow, I think. This isn't mixed operands, right? Okay, we have a C, we subtracted. They're not equal. Let's bump the pointer, copy from save. Copy to where that's pointing to. Those are 0. Oh, well, the first one I want to send through to the outbox as well. First off. Bump the pointer. Copy from save to where that's pointing. Get another one. Do that as well. So we need to loop through at this point. Instead of subtracting from the pointer, we need a loop here that checks all the ones we currently have. That's not correct. Make a loop down here to check through all the ones we currently have. So let's start it by having an initial count. We'll get the number we currently have. Subtract it from where we're pointing to. If it's 0, we already have it. We want a completely new number. If it's not 0, then we want to check the next number. Bumping the 2. If that's negative, then we're good to go on as well. It's not negative. I want to do this again. So if the count goes below 0, then we're done checking. That means it's not currently there. That means we want to do the out box. Negative point, do that. Okay, so what does that look like? Is that right? Looks a little bit weird, but oh well. B first off, put the B down. Compare the numbers we currently have. Save to count to. If it is a 0, we already have it. Get a new one. Put that into save. Did I have 2 B's in a row? I did. Or 3. Interesting. That's gonna keep doing that. C is new. So those are not 0. Count to is negative, so we're good. So bump pointer. Put that in the new spot and output it. Okay, I think this is right. So we first check that. Not negative, so check the next one. That is 0, so we've seen it before. It's a duplicate, get the next one. Okay. Check A to this, that's not it. Check it with 0, that's not it. Bump the pointer and put it in the new place. Okay. That was a little better than I thought. I just have to walk through my steps first as they're happening and then kind of formulate a plan. Can't have it all in my head. Not after doing it for... Think about that one problem for an hour really killed me. God, not for doing this for about 3 hours now. Okay. Speed is so close. If we could try a fewer step or even fewer commands. Let's think about it for a minute, maybe. I do want to set up the first one though. I guess I don't have to do this. That would have the same conclusion, yes? Yes, and that's one fewer step. Except that's wrong. Because I do have to do the first one first, yep. The B needs to go first. There's some spaghetti jumps in here. I'm trying to figure out if there's a better one. Copy 2 pointer and outbox. And then I go up here, but that's what copy to pointer and outbox are going up here. Right? Right here. If I move this jump there, get rid of those. I think we're good. Check the E. Check the D. Equal. Get the next one. Check the B. So that saved a couple steps. So look for duplicate code. That's my lesson today. Oh, missed it by one. By one! Oh my god. That's too close. Come on now. I suppose maybe somehow I don't need 2 counters for this somehow, maybe? Or use them a little bit less? What is this? Oh, this jump of 0 does nothing. Get rid of that. I knew I was right. Damn it, I knew I was right. Get rid of empty jumps, that's my second lesson. That's your second lesson for today. Duplicate code and jumps that do nothing. Especially if they're hindering you from getting the check marks. Look at that, oh we got it. I knew I was right. I don't care about the steps. I really don't. I want to look at it, but... One step off, really? I can save one somewhere by rearranging things? Probably. Excuse me. Happy to save. Be from pointer. The new count. Compare the save to all those. If it's 0, the next. Not 0. Well, we move this. Now we do need to save that off immediately. what if we did this up here? Does this even matter? From save, sub count 2. If it's 0, get a new one. If it's not 0, track count 2. If it's negative, then bump. Copy from pointer outbox. Otherwise do that again. I don't, that's probably the same amount. It might even be wrong. That's the same thing rearranged, so I think that'll be the exact same result for the optimization things. Maybe even worse, actually. Might be even worse. It's the same thing. I might call it. I might be done with this problem because I don't like looking at it anymore. I don't like looking at it no more. That the same thing. Rearrange it slightly. How does that affect the final result? It is more instructions, but is it less overall steps? No. No, what does it want from me? Be the same number though. I have a jump here for this logic. What if I move this logic up here? This, I can't copy multiple, which is annoying, but it's under the second one, yeah. Subtract it. It's negative, not negative. Negative bump pointer, copy from save to port. Get the next. Okay. Wanted a B, but I did 0. Now, is that right? This looks like it might be right. It still might be too many steps. Yeah, refactoring is painful sometimes. That was a lot for the last one. That might have been too much. Oh, there we go. Okay, that is what they wanted. Speed challenge. We got it with this. Alright, good. Bams. How many regular ones? We got this stupid hard one because I'm stupid. And it's 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Actually 7 in a cutscene. Okay, let's look at scavenger chain. Can possibly, it might have battery till 11. Getting a little drafty. Facilities management has been notified. Yeah, that you're missing half the building. We still have work to do. The world's, you know, having an apocalypse. But, you know, we still got work to do. We have tuples now, wow, but nothing to, you know, work with tuples effectively. Data, the address of another one. No, this is a linked list. A singly linked list. See, I know something about data structures and stuff. I don't know how to implement them in assembly, but basic idea. I've read about singly linked lists before. It has data and it points to another one. 13. Points to this. Points to 14. Or points to 3, sorry. 3, 10, 20, -1. Which that's the end. That's the tail. The head would be, or it could be the head. No, it'd be the tail. Any one of the, well, it'd have to be E. This would have to be the head. This goes, it goes here, 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 here. Yeah, so this is the head, this is the tail of the singly linked list. Although if we made this one equal 0, then it would be, you know, complete circular. A scrambled chain, each thing in the inbox, 023, is an address of one of the pairs. Outbox the data for that pair, and also the data in all the following pairs in the chain. The chain ends when you reach a negative address. Repeat until the inbox is empty. So this is an address. Okay, so I want to get the data. We'll have to put it somewhere, don't I? Yeah. Let's put it in 17. Copy from 17. So we want to get, let's pick up what's in there. We need to add 1 to that. Because they're all sequential here. Outbox the data for that pair. So I have to outbox immediately as well. Okay. And then copy from where that's going to point to, which this case is 0. Outbox that as well. Okay, and then bump this. Get the data where that's pointing from again. That'd be a loop. Get the data where it's pointing from, send it from the outbox, that's the data in the pair, the letter. And then bump it to get the address, and then copy from the next address. Okay. But we have to check. Copy the data from the address, this. We're bumping. Copying. We need to check if it's -1 somewhere, but let's see if this does it up until then. I wanted the E. Don't send it to the outbox. Okay, the data from there, put it on there. Okay. And then bump it to 24. We pick up... That's the 10. Oh, we don't want to send that to the outbox. Okay. Alright, let's do this. Copy from where that's pointing to. And if that's a -1, then we need to get the next inbox. Otherwise, we need to go to this address, which goes here. Okay, does this work? Get the data at that address, outbox it, bump it to get the next address, go to in the linked list. Get the number for that next address. If it's negative, we're at the end. If it's not negative, then get where follow the chain up and get the next singly linked list node data. Not negative. Oh, I need to copy that to 17. Yeah, so I'll have two. This isn't effective because I have 2 copies here, or I can put this here. Let's see, get the address, right? It's not negative, we're not at the end. That's the new one we want to get. The data from there, in there, okay. So this is a pointer to the current the current node that we're at in the singly linked list. It helps to think of it like that. It helps me to think of it like that. What is a real world use case for this data structure and algorithm you're building? Well, to finish a video game that uses that exact data structure and algorithm. But no, this comes in handy sometimes. Okay. 21 is negative, so we're done. We get the next one. There we go. That one wasn't that bad. That one was easier than the last one. However, maybe it would not have been easier if I didn't know singly linked lists, but it introduced a new concept, which was pairs of data and addressing. So I don't know. They probably meant for that one to be easier. That was cool. I like that, and I got both optimizations, like, first try. That's kind of unfair if you already know the data structures and algorithms first, I guess, but that's, I mean, that makes it kind of intuitive if you think about it. On to B6. Chessboard, and check, and mate. Yes, I win again. This is a matrix. Just a 2x2 grid, rather. I can think of it like X and Y coordinates. I find the game is most enjoyable when playing against the best player I know, myself. That could be a paradox for a robot. If you played yourself in a game of chess, would you win or lose? I mean, you could draw, technically. But I'm gonna do this one on the next stream. Each number is an address of a tile on the floor. Send to the outbox the coordinates of that tile, column first, row second. The coordinates of that tile, column first, row second. For example, this is a 4, so if we got a 6, an address of 6. Oh, okay, is the tile. It's 2, 1. So Y and then X. The coordinates. So if we got a 6, we would have to send the number 2 and the number 1. Interesting. You may ask your boss for more examples. 0330. 03. And a 330. Okay. I'm gonna do this one on the next stream. I'm well, my camera will die soon anyway from halfway battery when it cuts off. Yeah, I had fun. I know I spent like way too long on the triple thing. The triple sort thing that I could never finish. 3 sort. I may or may not look up a solution to that off stream, but you know, if I don't, I'll at least think about it some more. But I had fun. There's only 2 more regular ones and 4 more hard ones, including that 3 sort. So I think maybe another stream we can try to get close to being done. But yeah, I'll either stream tomorrow or this weekend. Tomorrow will be Tuesday for me. This weekend, either Friday or Saturday or Sunday. I am also editing stuff more, you know, as I get time on breaks, like lunch break from work and, you know, at night if I'm not streaming. So still got a few hours to edit for a couple of videos, which will take me several days because it takes more than 1 minute to edit down 1 minute of footage. Just how it works. But yeah, I had fun doing this. if somebody's watching this later, I appreciate you, man, really do, or woman, or whatever you identify as. Appreciate you. You're a good person. And yeah, hope you enjoyed. Maybe I'll catch you on a future stream. If not, that's okay too, but you know, hope you enjoyed and thank you for watching. I'll see you sometime in the future.